Good morning, students. Our today's topic is the application of Gauss theorem. This is one of the most important application, that is to find electric field intensity due to two thin infinite parallel sheets of charges. For this, let us consider two thin sheet like this one. Say charge sheet A, another charge sheet which is held parallel to the first sheet. This say it is sheet B. Let the sheets are positively charged, having uniform surface charge density, say sigma 1 and sigma 2. Okay. Now we have to find out the electric field at a point due to these two plane parallel sheets of charges. So if sigma 1 is the surface charge density of first sheet, and let that E1 is the electric field intensity due to first sheet, then it is given by then it is given by say E1 must be equal to sigma upon 2 epsilon naught, or we can say sigma 1 upon 2 epsilon naught. Say it is equation second, and let E2 is electric field intensity due to second sheet. So it is given by E2, which is equal to sigma 2 by 2 epsilon naught. So it is equation second. Now as both the sheets are charges, so we can write here the sigma 1 and sigma 2 must be positive. Okay. So now if we see the diagram, that then there are three regions surrounding the sheets. That is, say this is the first region, that is towards the left of A. Then this is the second region, that is between the two plates, and this one is the say third region, that is towards right of the plate B. Okay. Now if we see say first plate A, if it is having surface charge density sigma 1, then towards left at any point it must have a radial outward electric field, say it is called E1. This is the field due to first place, and towards this plate, towards the right of A, there are electric field radially outward. Say here it is radially outward in this direction, so it is also E1. And if we consider a point here, this point this point is also towards right of plate A, so in this region there is electric field E1. Okay. The field is remains same at each and every position, because the field due to a plane sheet does not depend on distance. Okay. Similarly, if we consider the plate B, this one, so we have to write the directions of electric field in different direction, that is towards the left of this sheet there are two portion. Electric field is radially outward. In this region it is E2, that is electric field due to second sheet. Similarly, this is the region first. In this also the electric field is radially outward, but towards the right the electric field this due to this sheet is radially outward in this direction, so it is E2. Okay. So from the diagram it is clear that in first region there are two electric field E1 and E2, and both are in same direction. Okay. Similarly, in region third, there are two electric field in the same direction in positive x-axis. And in the second region, there are two electric field opposite to each other. So we can write the electric field in third region. Third, you can say first of all it is in third region. Then net electric field, say it is E3, because it is in third region, which is equal to the sum of the two electric field, that is E1 E2. So it must be written as E1 plus E2, okay, which is given by E1 is sigma upon 2 epsilon naught as we studied earlier, plus sigma upon 2 epsilon. As it is due to first sheet, so it is sigma 1 and it is sigma 2. So we can write it as 1 upon 2 epsilon naught into sigma 1 plus sigma 2. So it is equation third. Okay. Similarly, electric field for the second region. Okay. For the second region, there are two electric field. If we consider positive x-axis as positive, so E1 and E2 is opposite to that, so we can consider it minus of E2. So there are two electric field, that is E1 minus E2. Okay, we take it minus sign because it is opposite that of E1. So here it is sigma 1 upon 2 epsilon naught minus sigma 2 upon 2 epsilon naught, which should be equal to 1 by 2 epsilon naught into sigma 1 minus sigma 2. Said equation 4. Now in the region first, the electric field is given by E first, which is equal to, in the first region, if you see, there are two electric field along negative of the positive axis, negative of the x-axis. So we can write it as minus of E1 minus of E2. So by putting this, minus of sigma 1 2 epsilon minus of sigma 2 by 2 epsilon naught, so we can take it 1 minus on 2 epsilon naught sigma 1 plus sigma 2. Say it is equation fifth. Okay, so now from these equations it is clear that there are different electric field intensity in the different region between or surrounded by the two plates. Now if we consider a special case, that is when the surface charge density on both the plate is same, that is sigma 1 sigma 2 both are equal. So let us consider a special case, that is case 1 is when sigma 1 equal to sigma 2, which is equal to sigma. Okay, so by putting this value in equation 3 4 and 5th, we get what, say, so from equation third, fourth and fifth, we get this: E in third region must be equal to 1 by 2 epsilon naught sigma 1, that sigma plus sigma, that is equal to 2 sigma upon 2 epsilon naught, or we can say it is sigma by epsilon naught. Okay, similarly from equation fourth, that is electric field in second region is minus sorry, that's 1.2 epsilon naught sigma minus sigma, that is equal to 0. And in first region it is minus by 2 epsilon naught into sigma plus sigma, that is equal to minus sigma upon epsilon naught. Okay, so now the special case second, when one sheet is positively charged and other is negatively charged, but the charge density is same, that is sigma 1 is equal to say sigma and sigma 2 must be equal to minus of sigma. Okay, so we can write it as a case like this. We have two a parallel sheet, that is first one having positive charge and the second one having this a negative charge, but the charge density is it is plus sigma, it is minus sigma. So now, as you know that due to this sheet electric field in this region is towards this, say it is E1, but due to this sheet, due to the second sheet, the electric field is in this direction. Okay, similarly here the electric field due to this sheet is in this direction and due to first sheet is in this direction. So that is E1 and this is E2. Okay, so now if we using the equation third, fourth and fifth and using the value of sigma 1 and sigma 2, we get from equation third we E3, that is electricity in third case is again 0. Similarly electric field in second case is that is 1 by 2 epsilon naught into sigma plus sigma, that is equal to sigma upon epsilon naught. And if we put in this 5 equation we get E first, that is equal to again 0. So we can say when two plane sheet having charge density sigma and minus sigma are placed parallel to each other, then the net electric field between the plates is constant and outside the plate is 0. So this is the one practical method by which we can produce a uniform electric field in a region. Okay, so that's all about this topic. So thank you very much.